Hello, I'm Paul Beckwith. In this video, I'm going to talk about a study that has just come out that has looked at the mean position of the jet stream in the northern hemisphere, mostly over the North Atlantic Ocean, over the last 1,250 years, using ice core proxies from Greenland. So ice cores dug into the ice, measuring the del 18O, or the isotopic abundance of oxygen 18 in the ice, and this is an indication of the amount of water that's fallen on Greenland in the form of snow over the years. And it's a really interesting study, and what it's basically showing is that the jet stream has shifted northward, the mean position, and that's going to continue to happen with rapid global warming. So I'll talk about the details of this peer-reviewed study. Just to recap, we know that the Arctic is warming much faster than the rest of the planet, and I'll show you the graph. It's basically about 4.5 times faster than the global average warming. So because the Arctic is warming so fast, we know the jet stream is slowing down and becoming wavier and getting stuck in place. And when it gets stuck in the ridges of the jet stream, we have warm weather and dryness, and in the troughs we have excessive numbers of storms. And because it's moving slower, the weather patterns, the storms are moving slower across the surface of the Earth, so therefore we're getting more persistent weather. And so storm events, extreme weather, is increasing in frequency, severity, and duration. And I have some specific sessions on this planned for the COP26 in Scotland. That conference runs from for the first 2 weeks of November. And it also explains why we're getting the weather weirding, the weather wilding, and weather whiplashing. And these are all phrases that I've come up with over the years to describe this, these crazy weather patterns that we're seeing, causing, for example, torrential rains in regions, leading to flooding, and also causing drought and soil drying out and in other regions. And both of those factors, if they happen over agricultural regions, they wreak havoc on our ability to grow food in these typically high yield agricultural regions. So anyway, I'll get right to the paper, right to the data. And I'll be talking about all these things again at COP, and there'll be live feed. I'm not sure if it's live feeds of the presentations. I think they might be doing that this time around. So let me just move my microphone here. So hopefully the sound quality is a lot better. So this is the article. Storm steering jet stream could shift poleward in 40 years. I mean, 40 years, come on, it's already behaving, very strangely now. But just a reminder, on my website, paulbeckwith.net, please consider donating on my PayPal, or there's if you want to support my travel to COP26, then please consider. I've got a GoFundMe site here. The link is here, and you can contribute directly to my transportation costs, etc., that are outlined. These are some of the videos that I'll be doing. I'm recording videos every single day on all of these different topics, and if have a good look at them, and I won't go through them all now, but I'm sure there's things missing which I need to talk about. So please let me know. And I'll try to incorporate them in my talks. Okay, so recently I talked about the Earth albedo declining. This is a very significant factor. And my Facebook page, you just search for Paul Beckwith on Facebook, and yeah, there's also a link here to my fundraiser. Okay, now Twitter. I tweeted this graph out recently. So this is Arctic warming versus global warming. There are 12-month moving averages, and the temperature change is relative to the 1951 to 1980 average. Okay, and what you can see here is you can see that global warming is increasing at about plus 0.20 degrees Celsius per decade. That's the slope of this dashed line here. And if you look at the Arctic warming has increased 0.87 degrees Celsius per decade. That's the slope of this red dashed line. So the Arctic is warming at about 4.5 times, about 4.5 times faster than the rest of the planet. So because the jet streams exist because of the temperature difference, the Arctic is warming so much faster that it reduces the temperature difference to the equator, so the jet streams have to slow down and get wavier. Now, what about the mean position? The paper I'm going to discuss is talking about how the mean position of the jet stream is expected to move farther northward. But I've talked about, recall my video where I said that the center of cold, when we lose all the Arctic sea ice, will shift to the center of Greenland, and that could offset and shift the jet stream actually southward over North America and northward over on the other side of the planet. So there's a lot of different factors that are at play in the movement, the mean position of the jet stream. This is a highly researched area, and it's not absolutely conclusive as to what is happening. So this is a key thing. For a long time, most scientists and the mainstream media and most people were dishonestly saying for quite a long time that the Arctic was warming at double the rate of the rest of the planet. But this data here clearly shows that it's more like 4 to 5 times, 4.5 times to be exact. And if you look back at some of my videos from many years ago, I've always said the Arctic is warming 4 to 5 times faster than the rest of the planet, depending on where you are. And this data shows that. So if you see any articles that are still using the 2 times number for the Arctic, you know that that's dishonest and that's not true. And if scientists are saying it, make sure you object strongly to it and just show them this plot. Okay, so this is the article, the news article. This one here is in Scientific American, but you can find it in lots of other. It appeared lots of other places. So this is Earth Null School, showing a typical position of the jet stream. That's the wind speed. If you go to Earth Null School and you select 200 millibar height or 250 millibar height, you see that's the height of the jet stream, and you can see the trough here and the strong ridge here and the trough here. And these ridges have gone right up into the North Pole, and the troughs have gone right down to the equator and met with jet streams from the southern hemisphere actually crossing the equator. That's been observed over and over again. And when I first pointed it out, I got slammed by the Washington Post. But, of course, it's proving to be true. Okay, so just to recap, the North Atlantic jet stream, it's a fast-moving air current circling the northern hemisphere, and it may migrate northward in the coming decades if strong global warming continues. That's what this paper is looking at, and it's based on looking at the position of the jet stream in the last 1,250 years. But there's other things going on because we're losing Arctic sea ice, and like I said, it'll shift the center of cold. So this is, keep this study in context with what I've told you in the past about jet stream behavior and shifts. But anyway, when it shifts, it shifts rainfall patterns, right? The storms get guided in different places. So there's an increase in droughts. There'll be an increase in droughts, heat waves, floods, and other extreme weather events in Europe and the eastern US. Okay, so the jet stream could basically shift outside the bounds of its historic range within just a few decades under a strong warming scenario. And the paper I'll discuss in detail was published in the Proceedings of the National Academy of Sciences. Now, it's a hot topic, excuse the pun, among scientists. The jet stream has a powerful influence on weather and climate patterns throughout the northern hemisphere, throughout the globe. Changes in the strength or position of the air current can have big ripple effects around the world. Okay, rising air temperatures, of course, affects the jet stream flow. And it says that the jet stream exists because of the strong difference in temperatures between the icy North Pole and the warm equator. The temperature gradient affects the thickness of the atmosphere, giving rise to wavy air currents that flow from west to east around the globe. And the air temperatures, of course, are rising steadily, but not all parts of the world are warming at the same rate. So recall this. The Arctic is warming 4.5 times faster than the rest of the planet, than the global warming average. Okay, and it says that there is discrepancy in the scientific community over what's happening. I mean, the jet stream tends to move around a lot as it is, shifting north and south, wiggling up and down as it moves around the globe. So to parse out whether the recent fluctuations are within normal boundaries or not is difficult. So this study looked at the jet stream position through history, looking back 1,250 years into the past, using they looked at isotopes, chemically analyzed samples of ancient ice drilled from deep within the Greenland ice sheet, and they looked at the oxygen isotopes to come up with the information on temperatures across, in that region, and they could tease out where the jet stream actually was. They could map out the flow of it because the jet stream has such a strong effect on regional weather and climate patterns. They could get those regional weather and climate patterns in the ice cores over time, and then backtrack and use this information to map out the flow of the jet stream throughout history. So for the past 1250 years, they found that the position of the jet stream, how far north or south it travels, it tends to move around a lot, but most of the shifts have been within the range of the natural fluctuation thus far. But they put it into the climate models and showed that it's likely to shift north over time. Now, like I say, this doesn't account for the Arctic sea ice vanishing, which will probably happen quite soon. So that will completely throw a wrench into this study because that hasn't happened over the period that they've looked at in the past. Now, the jet stream carries rainfall systems to southern Europe, which would otherwise be relatively dry. So if the jet stream shifts north, it could take that rainfall with it, increasing the odds of drought. So look out southern Spain, look out southern Europe. It's really going to stress those areas where the jet stream has currently passed through. Other parts of Europe, northern Europe, will see an increase in floods. And of course, if there's a drought in southern Europe, there'll be more heat waves, etc. And in North America, a northward shifting jet stream may amplify warming on the east coast and increase the severity of extreme weather events, droughts, and torrential rains leading to floods. Okay, so they looked at all of this. Now we know that climate change is making the jet stream wavier, but that information cannot be teased out in the ice core analysis. That's not what they were looking for. Okay. At the same time, the jet stream's position and its waviness could be related. Yes, they are. But some experts believe that a northward shift could result in a stronger, less wavy jet stream. A southward shift would result in the opposite. But so there's a lot of complexity in those sort of things. I don't think that will likely happen. And And they talked about Jennifer Francis and her work. She's devoted much of her recent career to studying Arctic warming and large air currents like the jet stream. And she's also talked about this tug of war happening, certain effects of climate change on the atmosphere, maybe pushing the jet stream north, while others maybe pulling it south. Okay, so it's still a very hot topic. So let's look at this paper. So this is a paper, North Atlantic jet stream projections in the context of the past 1250 years. Okay, so they've looked at all of those things, and I'm just going to pick out the main factors here. Significance, the North Atlantic jet stream, and they call it NAJ for short. It impacts North American and European societies and is expected to be influenced by ongoing climate change. So you need long-term records to put it into context. So they've looked at the position of the mean position of it from water isotope-enabled data, putting it into climate models. So they look at the ice core records from Greenland to reconstruct the mean annual North Atlantic jet stream changes back to the 8th century before Common Era. Okay, and basically it's a progressive migration of jet stream northward is projected to render it distinct from natural variability. Okay, so let's just look at the data. So this is the zonal speed, and this is the latitude. Okay, so this is the, you can see the, so right here, this is the, this is pegged at about 8 meters per second here, and this is where it peaks. It peaks at about 48 degrees north latitude. Okay, so you can see that position. You can see, you can do a statistical analysis and look at the principal component, and so these two, principal component 1 and 2, explain about 54 plus 31, which is about 85% of the data. And you can see two different positions here. This one here is coinciding with this point here, and then another mode is up here, higher at about 58 degrees north or so. And you can look at the statistics of these things and how they relate. I'm not going to go into all those details. You can look at the uncertainty of these principal components, and you can see the different locations on Greenland where ice core proxies were taken. And here's some of the results here. The position degrees north, it's extracted from the ice core. These are the observations. Okay, and then some average thing, and then there's uncertainty. Okay, so that's about, you can see the position, how it's fluctuated. This is from about 45 degrees north to about almost 50 degrees north, and then, it's become much noisier, recently, much larger excursions, much more variability in position. And you can also see that the intensity has, the noise, the variability has increased also, which is, we know this is happening. We're getting a lot more extreme weather events. And you can also relate the position of the jet stream at various times in the past. So this is the year here. Greenland was colonized. You get Greenland colonization here. A Great Famine here, North Europe famine, and so on. There's various things that are happening, and you can get the jet stream positions for those particular events. These are the mean positions. And you can see the trend in the jet stream intensity here. This is 1850 to present, and then a projection from the climate models, and you can see the general trend is an increase in the intensity of the jet stream. And also this is the position. You can see if the mean position here is 47 degrees north, up here it's more like 49 degrees north. So you can see, here's where we are here. This is the trend, and this is the model projection, and you can see, that it's trending northward. But again, this model, I don't think it accounts for loss of sea ice. The idea that the center of cold in the northern hemisphere will shift to be centered over Greenland, and I think that will cause an offset of the jet stream. Anyway, there's still uncertainty over what exactly will happen, but it throws a wrench into our ability to grow food. It will affect the global food supply. This is why I say when we lose the Arctic sea ice, it's going to be very difficult to grow food in many places of the world that are most prolific. And this is, there's an appendix here, or a supplement to this paper, and there's all kinds of statistical analysis and, principal component analysis. And I'm not going to get into these details, but you can see sort of, this is halfway through the atmosphere, 500 millibar, and you can see the, the jet stream will be in this location here. And it shows how some of these plots and stuff in the paper were derived, and these are different sites on Greenland where there are ice cores, and this is how far the record goes back from the ice core records, the year Common Era. Okay, and so this is part of the data that is used in the statistical analysis, and again, I'm not going to go into all of these details, but there's many sites. Basically, there's many sites where the ice cores were taken on Greenland. That allows you to get sort of the mean location of the jet stream, and then you can look at how it changes by doing climate models, and you can see how it's expected to change in the near future. So thank you for listening. I'm also going to do a jet stream video here, linking Arctic variability and change with extreme winter weather in the U.S. I'm going to talk about the state of the climate in the Arctic, and also the state of the climate in the Antarctic and Southern Ocean. And there's regional climates also. I'll pick some countries as examples. So have a look at some of these if you want. To start reading some of these reports, because I will be covering them soon in videos. The Ocean Observing System report card for 2021, okay, which is here, okay. Sort of summaries on ocean acidification, etc. This is some of the buoys that are used to measure ocean data. The oxygen, the Pacific, what's happening there, satellite-based observations, etc., etc. I'll be talking about that report. Also, this report here by the Global Oceanic Environmental Survey, and it's talking about how the ocean acidity is rapidly dropping. It's heading towards pH 7.95, and how that will devastate humanity. And then I'm going to talk about the Chatham House report that has come out recently. Climate Change Risk Assessment 2021. The risks are compounding, and without immediate action, the impacts will be devastating. We're already seeing that they're devastating, but these are upcoming topics. I'm probably going to do them sequentially in the order I've described them in this video. So, and by the way, I haven't abandoned doing 15-minute videos. But I'm doing longer presentations at the COP, so I'm just kind of getting myself in the time frame, getting a good understanding and when I'm presenting of how much time I have. So I will go back to, mostly to 15-minute videos, I think. But until the COP conference, I'll probably be doing some of these longer ones. Like I was hoping to get this one done in 15 minutes, but I've exceeded the time because there's lots to talk about. So anyway, thank you for listening, and please consider supporting my travel to the COP. You can go to my website, paulbeckwith.net, and do it directly through the website, or you can find the GoFundMe, and the link to the GoFundMe, which I've tweeted, it's in my Facebook, etc. Or you can just Google GoFundMe Paul Beckwith COP 26, and you can find the GoFundMe. I've also set up lots of people over time have told me I needed to set up a Patreon account. So I've actually done that. Some people prefer Patreon to other avenues, and so I've set up a Patreon account. And this is a question I have. This is interesting. This is this is 3 titans of quantum mechanics at a railway station in Stockholm, Sweden in 1933. And you can see Schrödinger here. He's probably got the cat in one of his pockets. But the interesting thing is, bow tie, really nice jacket, suit, and so on, and he's wearing shorts. And I was thinking maybe of wearing shorts at the COP in some of my sessions, just because, it's a good metaphor for, it's getting warmer and warmer and warmer, right? And it's interesting because the idea of wearing a suit and tie and being all dressed up and wearing shorts, that's common business attire, in a place like Bermuda. Anyway, thanks again for listening, and thank you for paying attention, and please share my videos and encourage people to follow me on Twitter and Facebook and Instagram and LinkedIn and all these other things. I do have a TikTok account. I'm going to try to do some 30-second videos and post them up on TikTok or whatever. I don't know what the time limit is. I saw a TikTok video that was about 2.5 minutes, so I don't know if there's a limit on that. But I need to, come up with something for that. Anyway, thanks again for listening, and bye for now.